What existed before the Big Bang, before the birth of our universe? This question has long been the stuff of coffee shop debates and late-night musings. The Big Bang, a colossal explosion from a single point, is widely considered the starting point of our universe. It gave birth to all the matter we know, from the smallest subatomic particles to the vast galaxies that dot the night sky. But what was there before the Big Bang? Was it a vast expanse of nothingness or an entirely different universe altogether? This question is not only intriguing but also fundamentally challenges our understanding of time and existence. The mystery surrounding what existed before the Big Bang is like a cosmic puzzle, waiting to be solved by the brightest minds. Physicists, cosmologists, and thinkers across generations have grappled with this question, each contributing theories and speculations. Some suggest our universe might have originated from an earlier, cold, dark universe. Others propose the existence of a multiverse or even cyclical models of the universe where the Big Bang is just one of many beginnings. Now let's delve into the theories and speculations that attempt to answer this enigmatic question. In the moments following the Big Bang, the universe was a hot, dense point of matter. It was an era of unimaginable heat and density, a time when the universe was but a cosmic soup of particles. Yet within this chaotic mix, the first matter in the universe started to form. This first matter was nothing like what we see around us today. It was not the stars, galaxies, or planets that we are familiar with. No, this first matter was the humble protons and neutrons. These were the building blocks that would eventually give rise to everything we see in the universe today. They formed around 1/10,000th of a second after the Big Bang. Before that, there was no familiar material. But even this explanation leaves us with a puzzle. If matter as we know it only formed after the Big Bang, then what was there before? To answer this, we delve into the realm of the extremely small and the extremely large, a period known as the Planck epoch. The Planck epoch is a time in the immediate aftermath of the Big Bang where our current understanding of physics falls short. It's a period where the familiar laws of space and time, as we know them, simply break down. It's a realm in which distances less than the Planck length, the smallest measurable length in the universe, become meaningless. It's a time when the universe was so hot and dense that the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, were all unified into a single force. In this realm, the concept of before becomes meaningless. Time as we know it did not exist. It's like asking what's north of the North Pole. The answer is, there is no north of the North Pole, just as there was no before the Big Bang. But the question remains, where did this matter come from, and what was there before? Quantum field theory offers a fascinating possibility. A realm where nothing is truly nothing, and the very fabric of existence continually hums with activity. This is the quantum vacuum, a sea of virtual particles that flicker in and out of existence in the blink of an eye. Picture a serene ocean, its surface calm and still. Suddenly, a wave appears, crests, and then vanishes as quickly as it came. This is akin to the concept of quantum fluctuations, where energy ripples in the vacuum, creating pairs of particles and antiparticles that annihilate each other almost instantaneously. Now imagine this process at the dawn of the universe, in the first 1/10,000th of a second after the Big Bang. There was no familiar material, no protons, no neutrons, just this quantum vacuum, seething with potential. Then, in an event known as the Big Freeze or cosmological natural selection, the energy of these fluctuations became so intense that particles of matter and antimatter formed and didn't immediately annihilate each other. This led to a surplus of particles over antiparticles, and these particles, the protons and neutrons, became the first matter in the universe. Quantum field theory suggests that the very matter that makes up everything we know, from the smallest microorganisms to the most distant galaxies, originated from these quantum fluctuations in the vacuum. The birth of matter, then, was not a singular event but a continuous process, born from the energy bubbling within the quantum vacuum. This theory offers a tantalizing glimpse into the origins of matter, providing a narrative of creation that begins with nothing more than energy fluctuations in a vacuum. It paints a picture of a universe that is dynamic and ever-changing, with matter and energy constantly transforming into one another. Yet, this theory leaves us wondering, where did space-time itself come from? While quantum field theory can explain the origins of matter, it still doesn't answer the question of where space and time, the very stage upon which all events unfold, originated. This remains one of the most profound mysteries in our quest to understand the universe. Physicists propose several captivating theories about the origins of our universe. One such theory suggests our universe may be the offspring of a previous one, not born from a fiery explosion, but from a cold, dark, and empty universe. This idea proposes that the universe we know and live in could be the latest in an infinite lineage of universes, each giving birth to the next in a never-ending cycle of cosmic rebirth. Then there's the concept of a multiverse, a theoretical cosmos containing multiple, possibly infinite, universes, including the one we inhabit. Each of these universes could have different physical laws, different timelines, and maybe even different dimensions. Imagine, somewhere out there could be a universe where time runs backward, or where gravity pushes instead of pulls. But perhaps the most mind-bending of all is the cyclical model proposed by the physicist Roger Penrose. Penrose envisions our universe as one phase in a perpetual cycle of expansion and contraction. In this model, the Big Bang is not the beginning but merely a transition from the previous cycle. Each cycle, or eon, begins with a Big Bang, expands, and eventually all the matter is consumed into black holes, which then evaporate and fill the universe with photons. This photon-filled universe then transitions into a new Big Bang, starting the cycle anew. This cyclical model challenges our conventional understanding of time and space, suggesting that they are not linear but cyclical, forever repeating in an eternal dance of creation and dissolution. While these theories are speculative, they spark our curiosity and drive us to seek answers. The question of what existed before the Big Bang remains one of the greatest mysteries in science. Our journey through time and space has brought us to the present moment, where the quest for understanding the universe's origins continues unabated. Physicists are like detectives piecing together the evidence of the universe's birth, and the clues are not easy to decipher. The Big Bang theory has given us a solid foundation, but it's just the beginning of the story. It's important to remember that the theories we have today are not set in stone, but are evolving as we gather more data and develop more sophisticated tools to analyze it. The concepts such as quantum field theory, which suggests that particles can pop in and out of existence due to energy fluctuations in a vacuum, have opened up new avenues of exploration. These theories are helping us to understand the birth of matter, the very building blocks of everything we see around us. Moreover, there's the intriguing idea of a previous cold, dark, empty universe that our current universe may have originated from. These concepts challenge our understanding of space and time, pushing the boundaries of what we thought was possible. But for every question we answer, another one pops up. The question of where spacetime itself came from remains unanswered. The Planck epoch, a period shortly after the Big Bang where our understanding of space and time breaks down, is still a mystery. We're still grappling with this enigma, trying to reconcile the laws of quantum mechanics with those of gravity. The theories suggesting a multiverse or cyclical models of the universe are speculative, but they're worth exploring. After all, it's through speculation that we often stumble upon new ideas and possibilities. Physicist Roger Penrose's proposal of a cyclical universe model where the Big Bang arises from an almost nothing is just one of many theories out there. The quest for understanding our universe's origins is far from over, but that's the beauty of science. It's a never-ending journey of discovery where every step brings us closer to understanding our place in the cosmos. As we continue to ponder and explore, we become more aware of our tiny yet significant place in the vast expanse of the cosmos.